Good afternoon, all. So, this is week 10 Microelectronics Device to Circuit Problem Solving session. I'm Arpita Biswas, a PhD scholar from Electrical Engineering Department from IIT Jodhpur. And this is more details about me. And this class session is every Tuesday, 7 to 9 p.m. So, let's start the session. So, this session we are going to discuss about some of the MCQ and some numerical question. So, this is the question number one. What is the CMRR of the 741 IC op-amp? So the first option is 90 dB, the second option is 80 dB, the third option is 50 dB, and the option fourth is 10 dB. So take your time, but at least try. So what is the right answer? So for the CMRR of the 741 IC op-amp is 90 dB. Okay. So next move towards the second question. So this is the question number two. In the given circuit for R in equal to 200 kilo ohm and Rf is equal to 500 kilo ohm, so calculate the output voltage V output for V input equal to 2 volt. So the first option is minus 5 volt and the second option is 20 volt. The option C is 10 volt and option D is minus 15 volt. So what is given here? The R input value is given here. The R feedback value is also given here. And the given value of V input is twice 2 volt. So we have to calculate the V output voltage. So what is the equation? How to find out the V output voltage? V output equal to minus of RF by R in into V input. So what is the value of V output minus of RF? So R feedback value is given here 500 kilo ohm and R input value is 200 kilo ohm. And what is the value of V input? Is 2 volt. So what is the value of V output? V output is equal to minus 5 volt. Okay. So what is the right answer here? The option A. So next move towards the question number 3. This is the question number 3. In the AC equivalent circuit shown in the figure, if I input in the input current and RF is very large, the type of feedback is. So carefully see the circuit and try to find out the answer. The first option is the voltage feedback. The second option is voltage current feedback. And the third option is current feedback. And the last option is none of the above. So take your time and then try to solve the question. So what is the right answer here? So see the circuit carefully. Here sampling is happening for the current and also mixing for voltage. Okay. So the given feedback is of type of voltage current feedback. So here the question number 4 is statement 1 is in an inverting amplifier, the output is inverted with respect to the input. And the statement 2 is in a non-inverting amplifier, there is no phase difference between the input and the output. So the first option is both statement 1 and statement 2 are correct. And the statement B is, option B is only statement 1 is correct. And the third option is only statement 2 is correct. And the last option is both statement 1 and statement 2 are not correct. So see the carefully the question, statement 1 and 2, and then try to solve the question. What is the right answer? So for this case, statement 1, in an inverting amplifier, the output is inverted with respect to the input. So this statement 1 is true. And what is the statement 2? In a non-inverting amplifier, there are no phase difference between the input and output. So statement 2, both are the correct option. So both the statement 1 and statement 2 are correct. Okay. So next move towards the question number 5. So see the circuit carefully, and the question is, when will the output get saturated in the following figure? First option is 120 second, option B is 150 second, option C is 128 second, and option D is 720 second. So take your time and then try to solve the question. To see, so what is the equation for how to calculate the V output? V output equal to minus 1 by RC integration of V of t into dt. Okay, and the limit is 0 to t. Now we have to find out the time when the circuit is in saturation. So next calculate it. V output equal to minus of 1 by what is the value of R? Here the value of R is 500 kilo ohm. And what is the value of C? The capacitance value is 10 microfarad. Okay. And integration of 0 to t minus, what is the value of V here? The V is minus 5 voltage here. Okay. Minus 0.5 dt. Calculate it. Minus and this minus will cancel out. And if we multiply and then there is 0.5, so it will come around 0.1 and the limit is 0 to t. Okay. Now see, output will be saturated when it attains the value of supply voltage, that is 12 volt. Okay. Thus the V output, which is 0.1, here we have calculated. Okay. Here 1t is coming. Okay, because this 5 and this 5 will cancel out, and from the equation here 0.1 only remaining, and the integration of dt is equal to t, and the limit is 0 to 2 t. So we can write down 1 into t. Okay, so this V output 0.1 into t will equal to 12 volt. So from there we can calculate the value of t. So here we can write the time required, time duration required for saturation of the output voltage, that is T equal to 12 by 0.1. What is the value of it? 120 seconds. So this is the answer. So at 120 second, this circuit output get saturated. Okay. The right option is the option A, 120 second. So next move toward the question number 6. So the sign of the phase margin in a stable feedback system is, the first option is negative, second option is positive, and option C is neutral, and option D is none of the above. So take your time and then try to give the answer. What is the right answer? In a stable feedback system, the phase margin, sign of phase margin. So the right option is option B. So next move over to the question number 7. The phase margin in a first order feedback system is the first option is larger than 90-degree, the second option is smaller than the 90-degree, third option is equal to 90-degree, and the option D is none of the above. So what is the right answer for the question number 7? The phase margin in first order feedback system is larger than 90-degree. So option A is the right answer. Next, question number 8. A method for modifying the frequency response of the loop gain involves the insertion of a dash. First option is Johnson capacitor. The second option is the Miller capacitor. The third option is the Newton capacitor. And the fourth option is the none of the above. So it is the right answer. So the right answer is option B, Miller capacitor. Okay, the Miller capacitor is the right answer. So this is the question number 9. Give the representation of the in circle point P and Q in the following step response curve of an op-amp. So carefully see the diagram. Here the P is denoting that portion, okay, and the Q is denoting that portion. So which option is the correct answer? So first option is P denotes the overshoot and Q denotes the undershoot. And option B is P denotes the undershoot and Q is denotes the overshoot. And the C is the P denotes the undershoot and the Q denotes the undershoot. And last option is none of the above. So try to solve the question. What is the right answer? Question number 9. So see the circuit diagram carefully. Here P is the overshoot, okay, and the Q you can see it is the undershoot. So what is the right answer? Option A is the right answer. P denotes the overshoot and Q denotes the undershoot. Okay. So next move toward the question number 10. For an amplifier or any other system to be stable, its pole should be lie in the dash of the S plane. So first option is the right half, the second option is the left half, third option is the top half, and option D is the none of the above. So try to find out the answer. What is the right answer? Option B is the right answer. This is the left half. Okay. This is the question number 11. The value of a feedback register and register connected in series with the input signal source are equal to 10 kilo ohm and 3.3 kilo ohm. So calculate the closed loop voltage gain. First option is minus 6.7. The second option is minus 33. The option C is 13.3 and the option D is minus 3.33. So please calculate it. So how to find out the feedback register closed loop voltage gain? So what is the formula for a closed loop voltage gain? AF, which is minus RF by Rin. Okay. So what is the value of RF? The feedback register is 10 kilo ohm. And what is the value of normal input resistance? It is 3.3 kilo ohm. So what is the value of it? Maybe equal to minus 3.3. Okay. This is the answer. The right option is option D. So next move at the question number 12. The inverting input inverting of the voltage shunt feedback register is a commonly named as the first option is terminal ground, the second option is virtual ground, the third option is virtual input, and the fourth option is resistive input. So what is the right answer? So the right option is virtual ground. Okay, virtual ground. This one. So next move towards the question number 13. So compute the RIF for an inverting amplifier with feedback where the value of input resistance of an of op-amp is 4.7 kilo ohm. So the first option is 4.7 kilo ohm, the second option is 9.4 kilo ohm, third option is 2.35 kilo ohm, and the last option is data given is not sufficient. Given data is not sufficient. So what is the right answer? Yes, the class is going on. What is the right answer? Mm. Just a minute to just wait for him. Am I audible? Hello? What is the right answer? Hello? Hello? Okay, let's calculate it. So, in voltage, feedback, amplifier, resistance, which feedback is given as RIF equal to R1 ideally. So what is the right answer? Here the value of input resistance is 4.7. Okay. So right option is 4.7. This is the question number 14. So specification of an op-amp 741C is given below. A is given 2 lakh, Ri is given 2 mega ohm, R0 is 75 ohm, and the supply voltage is plus minus 15 volt. The output voltage swing is plus minus 13 volt. And if 0 is given, 5 hertz. So compute the value of output resistance, bandwidth, and the closed loop voltage gain. So for the circuit shown. So first option ROF is equal to 8.6 mega ohm and IA if is equal to and frequency is given 5300 53005 hertz and AF is minus 9.36. ROF is equal to 4.12 mega ohm, IF and AFF equal to 53005 hertz and AF is equal to minus 11.78. And the option C is ROF equal to 7.1 mega ohm and FF equal to 53005 hertz and AF equal to minus 16.995 and option D is ROF equal to 1.9 mega ohm, FF equal to 53005 hertz and AF equal to minus 10. So try to solve the question. So what is the right option? So A value is given, Ri value is given, Ro value is also given, and the supply voltage is given. You have to find out the output resistance, bandwidth, and closed loop voltage gain. Okay, start to calculate. So the value of R output resistance, 25, ROF equal to R0 by 1 plus A beta. Okay, so let's find, at first you have to find out the value of beta, which is here it is 330 ohm and 6.2 kilo ohm. So the beta value 330 by 330 plus 6.2 kilohertz kilo ohm. So this value will come out around 0.053. Okay. Then we have to find out the ROF value. R0 by 1 plus A beta. So what is the value of R0 here? It is given. This is 75 ohm. So the R0 value is plus minus 75 ohm we can take. Then 1 plus, what is the value of A here? Is 2 lakh. And what is the value we have calculated? The beta is 0.053. So calculate it. It is coming around 7.1 mega ohm. Okay, this is the ROF. So from the first one, you can also see the which option is coming out. ROF is 7.1 mega. And the frequency, the bandwidth, this you will calculate. This one you can find out how much is it is 53005. It is same for all the cases. So AFib is 53005 hertz. Okay, and you have to find out the AF. So what is the value of AF? So you have to remove it. Here is it. Then what is the value of A minus A into K by 1 plus A beta? Now, how to calculate the value of K? It is RF by R1 plus RF. Okay. So what is the value of RF here? 6.2 kilo ohm. R1 is 330 ohm. This is ohm plus RF is 6.2 kilo ohm. Okay. So what is the value of K here? It is coming around 0.949. Okay. Then just put the value here. 1 minus, say, what is the value of A? 2 lakh. 1, 2, 3, 4, 5 into the value of K, 0.949 multiply. Mm, Then we have to find out the 1 plus A beta. 1, 2, 3, 4, 5. Into what is the value of beta we have previously calculated, which is 0.0535. Okay. So what is the value of it? It is coming around minus 16.95. This is the answer. So option C is the right option. This is the question number 15, which among the following is not a special case of voltage shunt feedback amplifier? The first one is voltage follower. The second one is current to voltage connector, and the third one is inverter, and the fourth one is none of the mentioned. So the right option is question number 15. The right option is option E. Why? Because the voltage follower, it has unity gain. Okay, it has unity gain. That's why this is not a special case. Which no, it's not a special case for voltage and feedback amplifier. So this is the question number 16. At what condition an inverting amplifier work as an inverter? So first option is R1 equal to RF plus RL. The option B is RF equal to R1 into V input by RL. And option C is R1 equal to RF. And option D is R1 equal to V output by V input into RL. Yes, the right option is R1 equal to RA. Okay. So this is the question number 17. Voltage shunt feedback amplifier forms a negative feedback. Option B is a positive feedback. Option C, both positive and negative feedback. And option D is none of the mentioned. What is the right answer? So the right option is negative feedback. Reason, any increase in the output signal results in a feedback signal into the inverting input, causing a decrease in the output signal. Okay, this is the next question. Question number 18. The negative feedback is an amplifier leads to which one of the following? First option is increase the current gain. So second option is increase the voltage gain. Third option is decrease the voltage gain. And the fourth option is decrease the bandwidth. So what is the right answer? So the right option is option 3. Decrease the voltage gain. How? Because we know that AF is equal to A0Y 1 plus A beta. So in negative feedback, an amplifier leads to which one of the following? So A0 here, A0 is the open loop gain. Okay. So in negative feedback is an amplifier leads to which one of the following? So this is positive. So this will decrease. So decrease the voltage and it will decrease the voltage gain. So this is the question number 19. The feedback amplifier basic question. So the question is application of negative feedback to a certain amplifier reduce its gain from 200 to 100. If the gain with the same feedback is to be raised to 150, in the case of another such an appliance, the gain of the amplifier without feedback must have been the first option is 400, the second option is the 450, the third option is the 500, and the fourth option is 600. So, what is the right answer? You have to find out the gain. So, how to calculate it? See, what value is given here? The feedback, gain without feedback is given. Okay, here we are going to start. Gain without feedback is given, which is A equal to 200. Okay. Then gain with feedback is 100. So first case, A, we know that AF equal to A by 1 plus A beta. Okay. This is the closed loop gain. And this one is the open loop gain. Yes. So AF is 100 and A0 without feedback it is 200. 1 plus 200 into beta. So now we can calculate the value of beta here. So what is the value of beta? Beta is 1 by 200, right? Now the second case. A closed loop is given 150, okay? And you have to find out the without feedback the gain. The gain of the amplifier without feedback. It's with feedback it is given. And you have to find out without feedback. So what is the value? How to find out? ACL, it's equal to A0 by 1 plus A beta. Okay. So ACL is given here 150. Then A0 is, we have to find out the value of A. 1 plus A into beta. Beta value is, we have already calculated, which is 200. Now from here, we can write here. So now calculate the value of A. So the A value is coming out 600. Okay. So what is the right answer? The right answer is option D, 600. So this is a question number 20. An amplifier has a voltage gain of 120. To reduce the distortion, 10% negative feedback is employed. The gain of an amplifier with feedback is, first option is 141, the second option is 92.3, third option is 9.23, and the fourth option is 1.41. Okay, so try to calculate it. I'm just coming back in 1 minute. So how to find out the value? So see, an amplifier has a voltage gain of 120 and the reduced distortion is 10%. Okay. A negative feedback is applied here and the gain of the amplifier with feedback is, so we have to find out the gain of the amplifier with feedback. Okay. So we know that ACL equal to AOL by 1 plus beta by AOL. What is the AOL? Open loop gain. And what is ACL here? Closed loop gain. And now here the value is given AOL. Okay, without feedback, it is 120. And the beta value is also given, which is 10%. 10% can we write 0 0.1? So now tell me, what is the value of ACL? 120 by 1 plus A into beta. A value is 120 into beta. Beta value is 0 0.1. So what is the value of AOL? 120 by 13. So this value is coming around 9.2307. Okay. So what is the right option here? 9.23. Option 3 or option C. Okay. So next move towards the question number 21. So this is the last question. Okay. An amplifier has an open loop voltage gain of minus 500. This gain is reduced to minus 100 when negative feedback is applied. The reverse transmission factor beta of the system is. So we have to, what is given here? The open loop gain is given and the reduced factor is also given. We have to find out the value of beta. So try to solve the question. So how to find out the answer? Here AF is given. Okay. The value of AF is minus 100. The gain is reduced to 100. Okay. And amplifier open loop voltage gain is 500. So without feedback, the gain is given minus 500. So A value is minus 500 and the gain is reduced to 100. So with feedback, the value is minus 100. So next we have to find out the value of beta. So we know the equation that AF equal to, what is the value of AF? AY 1 plus A beta. So A value is given here minus 100 and A value is minus 500. Then 1 plus A value is minus 500 into beta. Now tell me what is the value of beta? So from here we can write 1 plus A beta equal to 5. Then A beta is equal to 4. Then what is the value of beta? 4 by minus 500. So the result coming out minus 0.008. Okay. So what is the value of beta? Beta is minus 0.008. This is the answer. Okay. So today after this, we will meet again next Tuesday, 7 p.m. Okay. Okay.